Hello everyone and welcome back to Java Forever course. Today we are going to start a new unit called data structure. When we talk about data structure, at a high level, data structure is nothing but a group of data. If you remember, so far in Java, we have created individual data elements. We said int x equal to 10. We said int y equal to 20. We said int z equal to 30 and so on. In all of these three lines of statements, in these three statements, we are talking about three different variables and each variable holds a unique value. Now, how about if we could find a way where we can box them into single variable, and let's say we call it, let's say g equal to group, and we say this holds 10, this holds 20, and this holds 30. It's like a bunch of individual data grouped together in a single variable. That is what we refer as data structure. There are different type of data structures in Python, in Java, my bad. And one of the data structure is one-dimensional arrays. There are two-dimensional arrays, there are hash map, and so many different type of data structures in Java, and each has its own purpose. In this unit, we are going to learn about different type of data structures, their purposes, how to use them, how to create, and how to update those data elements within the data structure. Now let's focus in today's class on arrays. The one-dimensional array is a group of data, as you can see on the screen, in a box. Think of it as like a box in which you have three blocks, three compartments, and each holds its own unique value. Now the key or important part here is each data element is of same type. In this box, I can't say this is true. I can't say this is double quote Java and this is number 20. I cannot do that. Every entry in this list or an array has to be of same type. That is what we mean is it's a collection of homogeneous elements. That means data type remains same. It is homogeneous because all elements of the array are of the same data type only. That's one of the major restriction in one-dimensional array. Now, what really happens behind the memory? Think of this as, when we declare an array or any data structure in memory, basically you are, rather than reserving a room, you're reserving a group of rooms. It is like you're going to a marriage and, staying in a hotel. You remember how the whole party is kind of, wants to stay together, right? So same thing here. If you remember our hotel example, when it comes to memory allocation, we are talking about, earlier we talked about individual data elements all staying in one room. But now we are talking about reserving a whole floor or a part of the hotel in which, so not really a big room. So I would not draw this. I would actually, draw small rooms still, because the hotel has small rooms. But these all rooms are of same type. And these rooms are actually clubbed together in a block, saying, hey, maybe this floor, second floor or third floor of the hotel all belong to the same data type. So this whole memory, the room is still individually managed. If you declare 10, 20, 30, 40, 50, 60, 70, and 80, assuming you declare an array and you have 8 data elements, 10, 20, 30, 40, 50, 60, 70, and 80. If you declare 8 individual variables, you will be declaring like this. You will say, let's say A equal to 10, you will say int B equal to 20, and so on. That means this is A, this is B, this is C, this is D, and so on. And you will have 10, 20, 30, and 40. Now what really happens is, in this case, we are, creating a reserve area, and this blue box is basically a reserve area in which you still have the same size of the room for integer, let's say, small room. So all small rooms in one area. So the key to remember is in this one area, you cannot have two different type of rooms. If you reserve an area, you will all have like one room, one bed. If you may have a double bed or queen bed and all that like that. But idea is in one block, one logical unit, you cannot have two different type of rooms. If it is a small room, all are small rooms. If our one is integer, all are integer. If it is double, all are double. And collectively, we refer this as a data type. Let's say this is our data type G. Now G can be one-dimensional array, it can be two-dimensional array, and so on. Does not matter. When I say one-dimensional or multi-dimensional means 2 dimensions, 3 dimensions, and so on. Right? The advantage is that it can hold multiple values under one name. But then problem is, how do we refer individual rooms? Well, let's say G is a one variable that represents this whole area. But what about the individual room? The individual room is referred by its position number. So when we say this room is room number 0 of G. So when you say G of 0, it will be value 10. Rather than using variable A, now we are saying 0 of G. This will be 1, this will be 2, this will be 3, this will be 4, 5, 6, and 7. This is the position number of how the rooms appear in the order. And the leftmost is 0. And rightmost is, in this case, 8. So you can understand that the position number also referred as index. A technical word is index. We use index to identify or get the individual value. In this case, you will say A equal to 10. In future, I want to change, we can say A equal to 11, or we can say A equal to A plus 1, so on. What will happen is we are going and updating the value of A. But in this case, there is no A, B, and C. We always say G of, let's say 0, G of 1. You have to start with, you have to always give an index to refer a room inside this block. And we'll talk more about it when we get into the syntax part of it. But I theoretically or conceptually, I wanted you to understand what array is, what is single one-dimensional array, and how individual variables in the array is referred. How we don't really require multiple variables just to store same type of data elements. With that, I'll see you guys again in the next class. Go ahead and do the practice. Thank you for watching this video. See you again soon.
Thanks for watching. Do subscribe and press the bell icon for more videos.